Hello everyone. We're gonna be starting on our very first actual Python lesson. As we've seen before, we kind of looked at the insides of a computer in order to get a better idea of how the computer programming actually works behind the scenes. And now we are actually going to start on the actual code in Python. So a quick kind of overview of our class today. We're going to go over Python variables as well as Python data types, and then we're going to go and hop into an online IDE. An online IDE is essentially the program I told you guys to download last time, except everything is online. And the reason why I do this is because it's easier for you guys to see. Now, in this online IDE, we're going to kind of demonstrate all of the capabilities of variables and its data types, and kind of show you guys how it works firsthand. Without further ado, I guess we should get started. So there's a very famous graphics thing in Python, and it's known as Turtle. And so a lot of the basic Python books that you will see will usually jump into Turtle, and the reason for this is because it's very mesmerizing, and any kid who's trying to, say, get started on programming, this will get them very interested. But in writing Turtle, if you were to see this code over here, it doesn't exactly teach you what you need to know in order to actually start programming on your own. As you can see, there's all these lines of code. You're telling it to go left, right, up, down, and all these different commands. But in order for us to actually go ahead and examine what's going on here, you need to know every single component, from the variable to the methods to all these parameters to this loop over here. And so what we're going to do is we're first going to go to the very basics, and the very basics comes down to variables. And these variables are essentially very similar to the ones that you would see in like math. You store values in it, except instead of just storing numbers, these variables can also store anything from strings to characters to a lot of things in Python, and we'll get into the specifics later on. Now, the other basics in Python include the logic, so our Boolean algebra that we learned during the computer presentation, except in Python, in logic there are operators, there's tests, and there's loops. So operators is essentially just like the plus minus signs, all your like comparison signs, like equal, and we'll kind of show that later on. And there's also the tests, so that includes all of your if statements. So this is usually for just what its definition is, testing if a statement is true or not. And next is going to be the loop. So the loop is for the for and while loops. And so loops will allow us to repeat the same command over and over again. And so all of these lessons, they're going to be taught later on in this course, and the first thing that we're going to go into is variables. So the rest over here, input, output, functions, and collections, these are all slightly more advanced, and we'll kind of look into them later on into more detail. So I'll just kind of give you a quick overlook of how they go. So input, output, this means that anything you type into your keyboard, any sound that you input, or any like file from your computer, and that's going to be your input. Your output can be anything from sound outputting from your computer, or it can be saving something to a file, or even just the output in the console, just printing out what you just said. Functions is a way to package your code into something that you can constantly reuse, no matter it's essentially a way for you to be able to compact your code, and instead of having to copy and paste, you can just call the function, and it'll essentially do the copy and pasting for you, and it'll just repeat the same function over and over again. And finally is going to be collections. Collections covers a vast majority of, a lot of stuff essentially, because collections is going to be the way you can store your information. So you have variables, and that stores your kind of very basic level of data. And so this is going to be like single value, like integers, or usually they're associated with fairly simple things. Now collections is going to be essentially a storage for those variables. So a list is essentially going to be not one value, but perhaps 10, 100, 1,000 values. And you can see these examples down here. There's a list, tuple, and dictionary, and these are just 3 of the many different collections there are. And when we get to it, we can kind of talk to you about the basics of collections. So variables. So variables in algebra, we know that a variable will represent a number that is unknown. And when we use the variables in programming, essentially what we use them for is storing data. And as you can see over here, in this example, we kind of have the variable in the algebra form. And so we have these like coefficients, operators, and constants. So these are all technical terms, and these terms can also be kind of translated into programming, but right now we're only going to be focusing on that variable. So variables in programming are very simple. Essentially what they do is they store value. Now, in order for them to store value, we learned that the computer, in order for it to store information, it needs to put it into some sort of memory location. Now, in this case over here, the memory location is known as the memory address, and it's kind of consisted of these random, well, not completely random, but like this assortment of numbers and letters. And this assortment of numbers and letters will store the value of whatever the variable is trying to store. So essentially, what's happening here is this number is associated with this memory address, and this memory address will store the value. So when you call for the value of this variable over here, it will get the memory address that is associated with this variable name, and from the memory address it will retrieve whatever value is stored in that address. So that's kind of how the basics of a variable works. Okay, so with variables, there are 4 main things that we have to pay attention to. And these are 4 things that are going to be applicable in every single programming language out there. So this is kind of universal. It's not specific to Python. And so these 4 things are that A, there should be an identifier. So this should be, this can be anything like a couple of characters to a name that you want to use in order for you to remember it later on. So this is really just for the user in order to kind of make sure that they know what value they're storing or what the purpose of their value is. Next is going to be binding. So binding is essentially assigning a memory location to that variable. So assigning this memory location is very important, and we're going to kind of cover how the computer does it later on, or how the program does it later on, because as you can probably imagine, the data that you can store in a variable can vary in size, and so we all know that programming is all about being efficient with your resources. So we'll kind of show how the computer can kind of divide up all these different categories of data in order to store it in a way that's super efficient. And so next goes into types. So types is kind of like those divisions of data. So this allows you to show the type of value that's being stored at that memory location. And finally is something known as scope. So scope is known as the visibility of the variable. So this can be kind of confusing, but essentially what a scope means is the place where the variable is defined. So if we were to define a variable inside, say, something as like a function, so essentially a small block of code within a larger file, and we define the variable within this tiny function. If we were to try and call this variable outside of this tiny function, then the program wouldn't know what was happening because it was defined inside of the function. And so therefore the scope of this variable is within this function. And so there's a couple names we're going to go over it later on, but I'll let you guys simmer on this for a little because these are the four main things to know about variables. Now that you guys have had some time to think about it, we're going to move on into the more specifics of these four different categories. So the identifier. So the identifier allows us to put context to the value. So if we were to say like any number, like 23 in this example, 23 does not have any meaning to it because 23, well, what about 23? It can be, say, 23 cars on the road. It can be 23 people in a building. So this 23 does not have much meaning to us as it doesn't have any context. Now, putting the context of my number doesn't give us much meaning to it because, well, what does my number exactly mean? It can mean your age or your favorite number. And it could vary in what my number really means. Now, it is very important when you name your variables that you apply the right context to it, because this will allow you to, when you scan through the code, it will allow you to kind of make sure that the logic will flow soundly, and making sure that you name these variables in the proper way will allow you to kind of understand your code better. And so putting a value like number of students will allow you to kind of know, oh, the number of students is 23. Now, although this isn't like completely like, this isn't necessarily removing all like confusion, because it could be 23 students in a class or it could be 23 students graduated. But putting the number of students as the name will narrow down the possibilities by a lot, and typically in a program, as you have some sort of general goal, putting number of students will kind of allow you to fully understand the value, the number that you're or the data that your variable is storing. So the variable name, as I said, is only for the user, and so any like variable name that you put on there, the only use for it is kind of to make sure that you understand what is being stored in the variable, because when the computer actually takes in the value, it doesn't really consider the variable name. Instead, it will just translate everything into machine code, and the variable name will just be turned into, or it won't be turned into, but it will be replaced with a memory location. And so that's what you see over here, this compilation of numbers and letters. And so now the variable is now binded to this memory address. Alright, so now that you guys understand that, we can now move on. So, there's different types of binding, and the way that Python does it, it is known as dynamic binding. And so dynamic binding is kind of on-the-fly binding. So you guys can kind of read over this slide over here, but I'll kind of try and explain it. So essentially, what dynamic binding means is that it will kind of take the value of your data, or like whatever you typed in, and it will try and put a data type on it. So if you were to type, say, 600 into your as your variable data, then Python would try and see, oh, 600. Well, it's not a string because you didn't put the double quotations around it. But it seems like it's an integer because it's within like the range that Python defines an integer. And so what it would do is it will automatically define my number as an integer type. And so what this is called an interpreter, by the way. What this interpreter does is after it applies my integer value to my number, then the computer will know, okay, now that this is an integer, when you are to say add two integer types together, instead of just saying 23 plus 600 is 23,600, it would actually add the values together and then form a final product of another integer of 623. So this is known as dynamically binding. And so there is a different type of binding which is found in other languages such as Java. And so essentially what that type of binding is you have to define it yourself. So if you were to define my number is equal to 23, you would have to put int my number is equal to 23. And so the program would then know, oh, you're defining my number as an integer. So this is known as statically typed binding. And so statically typed binding is found in C++ and C as well as Java. And you need to make sure that you type in the value before you actually assign the data. So you can do it in two ways. There's this example up here where you define int my number, but you can also just insert an int over here and that would be fine as well. We're not going to go into the specifics with this as this is in Java and not Python, but essentially you need to tell the computer I'm trying to make this an integer before you can actually define the variable. And so this is good in a way because it allows you, or it allows the program to operate in a faster manner, because now it doesn't have to go like, what type of data type is this? Because you already told it what type of data type it is. Alright, so now we're going to get into the slightly more specific types. I'm not going to get into too specifics as we'll go over this in more detail later on. But essentially there's two main categories of data. So the first type is going to be primitive types. So primitive types is going to cover everything from your numbers to the strings and also Boolean. And so these are the three types of data that primitive will go over. And so primitive, as in its name, it doesn't store anything complicated. It's stuff that you can kind of type in on your computer in a couple of characters. So this is kind of a chart of your primitive types in Python as well as the bit sizes. It's not something that you necessarily need to know, but it is kind of cool to know to kind of see how the primitive how Python kind of stores your data. So as you can see, there's Boolean, and so that will be only 1 bit because the only values that can be stored in that is 0 and 1. So it only requires 1 unit of memory. Okay, so you guys can kind of look at this chart, but there's nothing really special that you need to know about this. It's kind of just something cool that you could know because, well, since Python is dynamic, then you don't actually need to put the data type before it. So the operations. So operations with primitive types means that you can kind of add two of the same types together. So computers, in order for them to be able to properly apply the operations, they need to make sure that they have the correct data types. Because if you were to say do a string 23 plus a string 600, then this would mean that the final value would be 23,600. However, if you were to add the integers 23 and 600, they would give 623. And so, as you can see over here, you have 23 plus hello world. And so this makes no sense because you're trying to add an integer and a string together, and the computer, not knowing how to adapt, will just give you a runtime error because it needs to make sure that the two data types are the same. So now we go into scope. So the scope or the visibility of the variables. So there are two kind of major scopes that we're going to go over. There is also, I guess, a sub-scope, I guess you could say. But the two main ones are going to be the global variables and the local variables. So the global variables means that you can access that variable anywhere in the file. That can be in, say, one say function. It can be in the main block of code. It can be in either class. And so essentially, no matter where in the file, you can always access these variables. And next, we're going to look at local variables. So local variables is going to be variables that can only be accessed within a certain block of code. Whether this be inside a function, inside a loop, inside an if statement. Essentially, these variables can only be accessed in that block of code where they were defined. And there's various reasons as to why you would want to define a local or global variables. Typically, local variables are going to be known as temporary variables, or variables that you're only going to need within that iteration of, say, the function or the loop. But as we get into more specifics with that later on, we can kind of see the true purpose of using global and local variables. So that kind of wraps up everything about variables so far in this presentation. So we're going to go hop into the specifics of the types.
Okay. Okay, so this is data types. So what exactly is a data type? So it's a classification that specifies which type of value a variable has and what type of mathematical, like operations, plus, minus, relational, or logical operations can be applied to it. So data types must be referenced and used correctly to ensure a program with no errors. So here's like a chart which shows like the data types like primitive mentioned before, and then it goes in more detail each time. So why are data types important? Each type of value requires a different size of memory to store it. So you need to specify which data type in order for the computer to know like the right amount of memory to store it. And operations can only be applied to specific types of values. So this was mentioned before. So for example, it's not possible to add text. So like you can't add hello plus world. That just doesn't work. So operations can only be applied to numeric values, int and float, which will be discussed later. So text type, string or str, it's used to represent text and it is comprised of a set of characters, which can also contain spaces and numbers. So for example, hello space world. Numeric types. Integer, int, it's a number without a decimal point. So the example here is 46290. A floating point or a float is a number with a decimal point. So here it's 46.2. So a sequence type. So a list is a sequence of 0 or more values. So a list is mutable. What this means is that you can change it, and that's the opposite of a tuple. So an example of a list is 1, 2, 3, 4, and 5. So the thing with the list is it has the brackets around it. If you see an example for tuple, it has parentheses around it. So a tuple is a sequence of 0 or more values, but it is um, not mutable, sorry. You cannot change it. Yeah, sequence can also have a string. So a mapping type, dictionary or dict. So a dictionary is a general purpose like data structure for storing a group of objects. So it has like a set of keys, and each keys has one single associated value. And then when presented with that key, the dictionary will return the associated value to you. And here's an example of that. So set types. Set is an unordered collection data type that is iterable, so which can be repeated, and mutable, which can change, mentioned before, and it has no duplicate elements. So example here is virus is bad. So it wouldn't be a set if it's a virus, virus is bad, because that has two the same elements. So Boolean types. A Boolean or bool, this was mentioned like 2 lessons ago. So it can only have 2 values, true or false. So Boolean logic is even embedded in other components of programming. For example, an if statement, it executes if and only if the condition proved is true. An example of this is just like true or false.
That wraps up this part of the presentation. Now we are going to move on to actual examples. Okay. So this is going to be our online IDE. This is going to be our the URL, I guess. So if you guys want it, you guys can just Google for this. Now, when we program this, we can say define a variable as letter, and so this can equal to say m, right? So when we have letter is equal to m, so this will automatically put the value of m into letter, right? So if we were to go like this and print letter, wait, I just made a whoops. There. Alright, so as we can see, the letter M printed. Now we're gonna go ahead and define number as 3. So if we were to go ahead and print number, then we get M and 3, right? So if we were to try and print letter plus number, you can see that it can't add the string and the integer together, and so it gives us this error over here, right? Now if we were to define number as a string, right, then it can easily add these two together and there's no issue. So now we're going to get kind of into the specifics of exactly how this plus works between an integer and a string. So as we can see here, we can have these two numbers or strings add together. So this is called concatenate, I believe. Yes. Now we can have second number, and we can define that as like 4, and we can add number and second number together, right? And so that will get us 7. So as you can see, you can perform the basic operations. You can say multiply them, right? So essentially you can do any math operations given the command, and as long as you get that right, then you will get whatever output you want, right? Now we get into strings. So strings are going to concatenate, which essentially just means they get added together. So if we were to have second letter y, right, and we were to add letter and second letter, then we would get my, right? So that kind of shows us that adding two strings and adding two integers won't kind of do the same thing. Now, say you wanted, when you add 3 and 4, you want 34. The way you would do this is you could just make these strings, right? And after you make them strings and you add them together, then you get 3 and 4, 34. And the only problem with this is that if you were to add these together, then this would be of type string and not type integer, right? So if you were to store that in a variable, then you would get a string type variable instead of an integer type, right? So now we're going to move on to kind of storing the value, or adding two variables and storing it in one variable. Alright, so we're going to go final letter is equal to letter plus second letter. And now you can see that I don't have any quotations around it, and all I have is the two variable names. So what this will do is it will essentially do the exact same thing as just this operation, or my. So we're going to print that out. And we can see that it prints my, right? So now we're going to go ahead and show that we can add the two numbers as well. And so this is just going to add 3 and 4 together. So we can just go ahead and print final number. And we can see that it adds the two numbers and prints out 7. And so what you can do is these kind of variables, so you can add them together, you can store them in another variable, and there's a lot of different other kind of specific operations that we can do. Say for a number, you can multiply them, you can divide them, as long as it's a math operation. Again, same thing as printing, you can store it in the variable. So that will be all for this class. If you guys have any questions, just type it in the chat, and we will try our best to answer you. I guess that will be all for this class. Thank you everyone for watching, and see you guys on Tuesday, I guess. Test. What do you mean by accept new members? I'm not quite sure what you mean by that. Oh, you mean our team? Um, well, that would be I guess a team decision, as we are going to be moving on into like our, I think, sixth year together. I'm not sure if as a team that would be something. But you can definitely just ask on WeChat, I think, or contact our coach via WeChat. But other than that, I'm not exactly sure what we would have to say about that, I guess. But thank you for asking. And by the way, do not forget to do the homework. It is uh, very important in making sure that you learn this. And later on, we're going to be introducing something known as Coding Bat. You can check it out yourself right now if you want. It's going to be called codingbat.com. Oh man, I googled that. Okay, and so this is kind of what CodingBat looks like. So there's a Java section. You're going to want to click on Python right here, and there's all these questions over here. If you want, you can jump into these, but we're just going to be kind of looking at these in more detail in the later classes. Alright, thank you guys for watching, and see you guys on Tuesday.